You must have seen a windmill. After all, around 6% of Pakistan's total electricity needs are fulfilled by wind power. That also stands as a fact that Pakistan's wind energy is a highly unexploited domain. A windmill is one of the most basic means of deriving electricity from wind energy. The tall and sturdy column that is made up of resins, plastics, steel, iron, and carbon fiber lifts the turbine above the surface of Earth. That's why when you look at a windmill, one of the first thoughts that comes in your mind is, what a huge, giant structure. Well, it sure is beautiful, but it costs a lot of money. The average windmill height is approximately 60 to 80 meters from the surface of Earth. This is in order to allow the turbine to access the high wind speeds present at that height, so it is able to generate enough amount of electricity while being economically viable. And that's exactly what eats most of our money. More than 26% of the total cost of a windmill is taken by the tower and the foundation that rests beneath it. We're 4 engineers from the School of Mechanical and Manufacturing Engineering at the National University of Science and Technology in Pakistan, and we want to save that money. Let's think out loud here. Is there no other way of lifting a turbine to a height of 60 or 80 meters above the surface of Earth without utilizing the huge amount of material, labor cost, and the engineering complexity involved in making a windmill column? There sure is a way, and we call it the Airborne Wind Energy Harvesting System. We have designed a sailplane or a glider that is capable of lifting a generator to a height of approximately 100 meters from the surface of Earth. The proof of concept is capable of carrying 10 kilograms payload and turns off its engines at the height after receiving lift from the incoming wind and also from the thermal soaring currents of the Earth. As a result, it is capable of gliding or sailing for a very long period of time without the requirement of electricity and therefore producing electricity via the generator mounted on it. After completion of the research, design, as well as the computational fluid dynamics analysis, as well as some finite element analysis of our design, we are already in the process of manufacturing an assembly of our sailplane while also looking for funding in order to complete the whole project, including the control systems involved.